Hello everyone. Today we're going to talk about pulse TIG a little bit. What is it? What's the point? Why to use it? How to use it? First off, one of the greatest things that I've found, I really don't like using pulse TIG. I'll get that out of the way right there. But the one benefit that I've really found on it, I just got a piece of scrap steel here. So say you added something and you were trying to repurpose it and you needed to build up along this edge here. So this right here is 1/4 inch thick, just cold rolled steel. But you know, it'd be hard to keep this profile and actually kind of build up along it if you didn't. So here's one that I just did in pulse TIG. Kind of build up that profile right down through there. You can see it bit in good. You got decent penetration, you know, to build this profile up. So you need to remachine this part. So this wasn't just a scrap piece and you need to remachine it or you need to do something, but you're trying to build this edge up. So it doesn't distort the crap out of it, and kind of works good for that. So this is a primeweld 325. First off, you know, you want to be in TIG. It's cold rolled steel, so you want to be DC. Then the amperage, normally, if I wasn't running pulse TIG, I would run approximately 1 amp per 1,000. That's 1/4 inch thick. So I'd run it at 250 thousandths or less. Because of the pulse, you don't put as much heat input into the part, nowhere near as much. So you have to run a little higher on the amperage. So that's something to note. I just made that weld on 191 amps. I had the foot pedal. I wasn't full pedal the whole way. But so there's this. The easiest way to remember on the pulse TIG, if you're doing something like that, it's called the rule of 33. So you want to set your base current to 33%. So that's 33%. What you're telling us, 33%. So then your pulses per second, I was doing 33 pulses per second. So it means every second it's kicking on and off, 33 times. And whenever it kicks off, it'll go to peak amp. And then it'll go back down to the base current of 33%. And then your pulse duty, set it to 33. And then, you know, because to get to 33 pulses per second, we had to be in the high pulse. This machine on low pulse only go to 10 pulses per second. But because I was doing the knife edge and on the thick steel, that's what I ran with. So I'm going to try to mesh these two videos together. I'm gonna get set up and try to do an arc shot to show you all what that looks like. So as you can see, that pulse allowed us to build up on that edge. So we didn't chew away at the base metal down here. See? That's a good thing about the pulse. If you needed to save this part, say that was, you know, something that this is a very expensive part and it was machined wrong or something and you were needing to build this edge back up so it could be remachined, that's one thing that you can use the pulse. Now I'm going to do one more pulse up here. And then that way you can see what it looks like out in the center. And then I'm going to step down, and in between them, I'm going to do one without pulse so we can kind of see the differences. Make sure to subscribe and hit the bell button. Help us out. Another thing to take note here is the puddle. The pulse TIG makes it harder to focus on the puddle. You can see how it makes it very bouncy, and that's where the arc is pulsing back and forth. That's another thing that I don't like about pulse TIG, besides the fact of the sound is absolutely terrible. This is the final arc shot of this video. This is without pulse. First off, the sound's way better. And notice that the arc is very stable and it's not jumpy. The puddle's very stable. It's a lot easier to see what you're doing on normal DC TIG welding. All right, so now we got that done. That's what we did. Here's the one with the pulse TIG. These are all the same amps, everything on the edge. You can see how, like I was talking about, it held up on this profile here. It didn't melt this edge away. So you didn't deform your edge, didn't melt it away. Now the next thing, when I stepped up in here and just did one with the same exact pulse settings across the top, you can see how much more raised this weld is. It didn't sink in, wouldn't get enough penetration. So, I mean, you really wouldn't want to do this out here unless there's a special need for it. But I just wanted a side-by-side comparison. So then on this one here, I let the plate cool down. And only thing I did was I just reached over on the welder and turned the pulse TIG off. I left all other settings the exact same. And you can tell, remember how I talked about whenever you run pulse TIG, you got to go up on your amperage? That 291 amps was just too much amps. Honestly, I didn't even run full pedal the whole way out or anything. Like I was still only probably 3/4 way pedal, and it started washing out on me real bad right here. So I had to back up off the heat. Now, imagine, even if I had the machine, like I left this just for side-by-side comparison. I knew it was going to be too hot on this one. But even if I would have backed it down to say 225 or something on my amps, 200, coming across this edge right here with no pulse and trying to not distort it, you'd have probably had to start, doing the pedal pumping. You'd have probably had to, do your own pulse TIG kind of with the pedal or something, because what you would have found is once you got started, it just started trying to wash out. That bead would not have laid up on there. That's one good thing pulse TIG does. It'll let that bead just lay up on that edge. It also works really great for thin metal, trying to not get it to distort and warp and stuff. So hope this helps. That's kind of a rundown on the fast and dirty of pulse TIG.